A generator is a device that converts mechanical energy into electrical energy. It is also known as an electric generator or dynamo. Generators are used in various applications, ranging from power plants that generate electricity on a large scale to portable generators used for backup power supply. Here are some key aspects of generators in electrical engineering. Principle of operation. Generators work based on the principle of electromagnetic induction, which was discovered by Michael Faraday in the early 19th century. According to this principle, when a conductor, such as a wire, moves through a magnetic field or when a magnetic field changes around a stationary conductor, an electromotive force, EMF, is induced in the conductor. This induced EMF causes a current to flow if the circuit is closed, thus generating electrical energy. Types of generators. Generators can be classified into different types based on their construction, application, and power generation capacity. Some common types include 1. Alternating current, AC, generators. These generators produce alternating current, which periodically changes direction. AC generators are commonly used in power plants and residential applications. 2. Direct current, DC, generators. These generators produce direct current, which flows in only one direction. DC generators are used in various applications, including battery charging systems and portable devices. 3. Synchronous generators. These generators operate at a constant speed and produce AC power that is synchronized with the grid frequency. They are commonly used in large power plants. 4. Asynchronous generators, induction generators. These generators do not require a separate power source to establish a magnetic field. They are often used in wind turbines and other renewable energy systems. 5. Diesel generators. These generators use a diesel engine to drive an alternator and produce electrical power. They are commonly used in remote locations and as backup power supplies. Components of a generator. A generator typically consists of the following components. 1. Rotor. The rotor is the rotating part of the generator that contains a magnetic field. It can be either a permanent magnet or an electromagnet. 2. Stator. The stator is the stationary part of the generator. It consists of a set of windings or coils that are connected to the external circuit. 3. Exciter. The exciter is a small generator within the main generator that provides the initial current to the rotor to establish the magnetic field. 4. Prime mover. The prime mover is the mechanical device, example, a steam turbine, gas turbine, or diesel engine, that provides the mechanical energy required to rotate the generator's rotor. 5. Voltage regulator. The voltage regulator controls the output voltage of the generator and ensures that it remains within the desired range. 6. Cooling system. Generators generate heat during operation, so they typically have a cooling system, such as air or liquid cooling, to maintain the temperature within acceptable limits. Applications of generators. Generators have numerous applications in various sectors, including 1. Power generation. Generators play a crucial role in power plants, where they convert mechanical energy from sources such as steam, water, or wind into electrical energy for distribution to homes, industries, and commercial establishments. 2. Backup power supply. Generators are used as backup power sources during power outages or in locations where access to the electricity grid is limited. 3. Construction and mining. Portable generators are commonly used in construction and mining sites to provide electrical power for tools, lighting, and equipment. 4. Telecommunications. Generators are used to provide power backup for telecommunication towers and network infrastructure to ensure uninterrupted communication services. 5. Emergency services. Generators are essential for emergency services such as hospitals, fire stations, and police stations, where a continuous power supply is critical for life-saving equipment and operations. 6. Recreational and residential use. Portable generators are popular for recreational activities like camping, boating, and outdoor events, as well as for residential backup power. It's important to note that generators are not 100% efficient, as they incur losses due to factors such as resistance in the windings, friction, and heat dissipation. However, they remain an integral part of our modern electrical infrastructure, providing reliable power generation in various applications.